I'm Devat Solanki. I am third year PhD student in Kalyan College of Engineering. I work with Dr. Robles, and we have different labs in College of Engineering as well as College of Technology. I'm going to share my screen and show a pre-recorded video which describes both lab and equipments we have in lab. David Solanki. I work with Dr. Robles, and in this video, I'm going to show a few equipments which we have in this lab. To begin with, this is a tensile tester. This is used to characterize metallic samples to see how for the tensile stress. And on the other side of the room, uh, let me show you. Here we have a couple of other saws for cutting blades, and then we also have a Rockwell and Greener hardness testers over here. And over here we have micrometers hardness tester. This is used for micro hardness measurements. One of the main advantage of this equipment is it forms very small dent on the surface, so it's not that much destructible for samples which we have to use for other applications. All of these equipments are used for teaching of 4172 lab as well as research purpose. And over other side of the lab, here we have a few microscopes in this room, and here we have different grinders. These grinders basically have a conveyor belt type of mechanism, so we can change any grip size of the belt, and then when the belt rotates, we can put our metallic samples on top of it so that we can grind them and polish them eventually. And over here on the left side, we also have a hood in case if you want to work with any chemicals which generates fumes. So this gives brief introduction about equipments present in the College of Technology. Thank you. Here in the engineering building, we have a induction heating system. This is cooling system for an induction heater, and this is basically entire system. And this is the coil. So one of the main advantage of this system is that we can heat sample in a very tiny area mentioned here within the coil, and we have IR sensor from here. So this IR sensor focuses in middle of the coil on the sample, and one of the main advantage of this equipment is with this we can ramp up heating very fast. So within few seconds we can reach to almost 1400 degrees Celsius. So this machine is used for many sintering applications as well. Thank you.
Hi everyone, my name is Natalie. I am first year master's student of College of Technology. I am working with Dr. Robles, who is my advisor. This is a Raman lab, and here we can see the Raman spectrometer. We are working on characterization of superconductor samples. So what we do is we install the sample and we shoot the surface with a characteristic laser, and the reflection is detected. We can analyze through this software. So what we can see here is the differences on the structure or the surface of the material. So superconductors have characteristic peaks that tell us that the structure is homogeneous. However, in this sample, we also can see a different peak. In this case, that is telling us that the sample has a defect. So through Raman, what we can do is analyze composition, structure changes. So we can use this equipment to characterize our samples, and we can say if the samples are in good condition or not. And in this way, we can control the quality. So through Raman, we can analyze different kind of materials, can be liquids, gases, solid, powders. So this is a brief summary of what we are doing in Raman Lab. Thank you.
Hello everyone, my name is Amrita. I'm a master's student at College of Technology. I'm working with Dr. Robles on synthesizing the bioplastic with the kind of second importantly. We use mechanical milling to mix with the polymer. nanostructures and make one composite with it. Initially, we used to use a French press and heat it externally to settle the products. Now we've come up with an innovative mold which has threaded combination of high pressure, and then we put the full assembly in the fridge in the heating furnace. We believe that this biopolymer will find applications in manufacturing electronic circuit boards, battery batteries, and various other bioplastic resources. Thank you.
Hello everyone, my name is Miyad Yareli. I'm a PhD student in Material Science and Engineering program at College College of Engineering. Dr. Robles and I are working on a project where thermite weld improvement for the rails application is the goal. Within the thermite weld, there are many voids and defects that are a result of precipitation of the gases during the solidification. These voids are the initiation site of cracking. Therefore, improving the fatigue resistance of welded rails is a major goal. Our approach to improve the thermite weld performance is to introduce a vibration using two electrical motors during the solidification. In our setup, you can see that we use these two electrical motors, and in between we have a mold that we fill it with water and some suspended particles. The weld treatment is proposed based on a design of experiment where we investigate the effect of some factors such as frequency of the motors, impact loading condition of the motors, motor position where we counted parallel or perpendicular to the rails, and motor location close or far to the mold. We simulate the effect of these parameters at UH. In a dark room, we shine a laser on top. We turn on the motors on a specific frequency and a specific location, and those parameters, we set those parameters, and in front we capture the images using the camera here. And then we give these images to PIV lab. PIV lab is a MATLAB tool that can calculate many parameters like vorticity, velocity, or shear of the particle. And at the end, the PIV lab gives us a contour, velocity contour or shear contour. Then we can optimize the condition, and we can have the best condition where we have the least voids in the weld. Thanks.
Hello everyone, my name is Robles and I'm a first-year PhD student in Material Science and Engineering. I've been working with Dr. Robles for almost 4 years, and my specialty is in FTIR. So FTIR is one of the most useful analytical techniques that we can use to study any samples in almost any state. And it's the basic of the FTIR is based on the vibration of the atoms in a molecule. Here we can see the FTIR that we are using. Our system is in situ FTIR. So after running our samples here, which our samples are mostly the solids.
Yes, hello. This is Francisco Robles. I just want to mention what's the interest of our work in the Brain Center. The main goal of our projects is to develop materials for different applications. For example, what Amruta proposed is materials that are completely degradable and compostable, and we can make biomaterials, biocomposites that are probably a good source of structural materials for exoskeletons, and those exoskeletons that are non-permanent or long-lasting equipment, they can be literally broken down and decomposed on soil or any environmental in an environmental manner. Another project that we have in collaboration is with Professor Ramana and also Dr. Vidal, and we are trying to develop a technology where we use smart materials instead of motors for exoskeletons, and how the mobility in the exoskeleton can be developed based on the induction heating and all other kind of technologies in order to activate or magnetic fields in order to activate the smart materials. The smart materials are mainly used for hands and probably for other prostheses like legs or knees or whatever is needed, as long as we can put some smart materials, smart wiring, so that we can activate them and remove all the motors. Hopefully, this will reduce the weight of the and the complexity of the exoskeletons.